Join me in welcoming Krishna.
Thank you. Thank you. Yeah. So today we are going to talk about the PostgREST with PostGIS. I had a workshop about the same topic on Tuesday, and that was really interesting because we had like a lot of people who were experiencing the power of PostgREST for the first time, and it was really eye-opening because you can do so many things with PostgREST that it essentially helps you out to build like quick MVPs within few hours. So can I get a show of hand? How many of you use PostGIS in their project, like on an everyday basis? Almost everyone. That's awesome. All right. So the idea of this talk is to actually tell you that if you have a database, there is a solution that will help you to spin up an API system or a backend without you having to write anything for your entire database. You get to control what tables you want to expose. You get to control what all endpoints you want to expose, like post or put or delete. And then you also get to control that if you write a function, do you want that to be also converted into API? So everything that you do in a database, which means authentication, creating data, writing functions, creating views, everything is available to you as an API without you having to write a single piece of code. So that's exactly what PostgREST brings to the table. So what we will cover is a basics of Postgres and PostGIS. I'm pretty sure like everyone here knows that, so I'll try to skip through those slides quickly. Then we will look at the PostgREST setup and how to auto-generate the REST APIs. Then we will have a look at the authentication, so that even if you're using the users and roles and passwords within Postgres, you can still convert them into a JWT token and then use that to authenticate your APIs. And then how do you write custom functions or business logics and then expose them as an API endpoints. We will also have a look at the Spatial APIs, which means obviously location-aware APIs. You can either create APIs where you are giving location, or you can either create an APIs where you're expecting location data back from the database. We'll have a hands-on demo if possible, because everything is live. So why PostgREST? It's essentially a zero-code API, which turns your entire database schema into REST APIs automatically. So you can connect one or multiple schemas together to actually convert them into API endpoints. So traditional API development starts with you having a backend, you having a database first, where your business logic, your actual data, it can be vector data or let's say any data, plus your authentication data lives. Then you build a backend code, then you build API routes for every single thing that you want to do. Then you build an authentication, and then you also build a validation for either the API endpoints, which means for example, people who are in Python world, like your Pydantics. And then you build validations for APIs as well, so that the authorization is being taken care. Then you write document, and then hopefully you write document, and then you actually submit that to the client, which means either your front-end guys or someone like that. But the problem is that there is a lot of boilerplate code, and it's a maintenance overhead, because every time if you make change to the database, if you are using ORMs or let's say migrations, then it's fine. But if you're not, then if you make change to the database, you have to go through the entire procedure again. So the approach of PostgREST is a bit different. So you just write PostgreSQL schema, and then just connect that to PostgREST, and then that's all. You have REST APIs that you can just share with the client. Benefits is that it is completely auto-generated. It is always in sync. So if you make change to your database, let's say if you add table, or if you add schema, or if you change the authentication, you can just recreate this open API document, and then it's always in sync, and it's minimal configuration. There is a workshop available for this particular talk, which is available at this link. It's postgres/ws.rottengrapes.tech, and I created this like few days ago. So feel free to check it out. Feel free to open the issues, which covers everything. So essentially, if you are someone who also wants to go through the Postgres and PostGIS a bit, you can just check out. This contains everything. And the only thing that you need to do is like just simply do Docker compose up and then build. The reason why we do build is that I have actually taken the I've actually taken the Docker, the PostGIS Docker image, and then I have made some changes to it. And the reason why we want to do that is because we also want to include PGJWT extension, which is not available in the latest PostGIS 17, like Postgres 17 version. So the Docker Compose contains the build for the PostGIS, then PostgREST, and to be honest, this is the only mandatory thing in this entire Docker Compose. Everything else is optional. Obviously, if you have your own database, you can connect that. pgadmin, Swagger UI, and mkdocs for building the documentation. So you get multiple endpoints. And let's have a look at PostgreSQL, the foundation of this entire thing first. We'll have a quick look at this. So Postgres supports the JSON and JSONB, which means that if you're looking for a NoSQL use case, Postgres is still a valid database for that, because you can store the data in dictionary format or object format, whatever you want to call it. And then you can actually filter the data based on that object itself. So you can go within a dictionary or that object, and then you can keep going within if you have a nested object that you have. It also supports array, which means that you can store multiple values in a same column. This you can also restrict it by putting the type of the data that you are expecting in an array. And then you can also make custom types. And this is really wonderful because a lot of times we want to restrict user to put certain kind of information in a column. Maybe let's assume a category of a workshop. So it can be technical, it can be analytics, or it can be business oriented, for example. So you can only expect these three values and nothing else. So all these things are possible. And then you can also write functions. So unless and until you're not going to use an external, let's say, package or something like that, you can use Postgres to write functions which might take the data from one of the tables itself, or it might not take. You might want to write a function where you are giving the parameters and you just want to run some statistical things. So those functions are readily supported in Postgres. And obviously it comes with an extension like PostGIS, pgcrypto, pgjwt, etc. You can also do row level security, which makes life very easy when you are creating a production build application. You want to only expose certain rows, or if you want to expose only certain columns to the, depending upon the authorization and authentication, you can do that. PostGIS integration. So PostGIS, without a doubt, one of the most widely used geospatial tool out there with Postgres. You can create geometries of various type: point, line, polygon, multi-point, multi-line, multi-polygon, or even a mixed geometry. And you can also assign projection system to it, which makes it very much useful for various use cases. Now let's have a look at the PostgREST API magic. So let's assume that we have this table known as workshop, where we have ID, title, duration, and instructor. Now, in order for us to make an API out of this, there are a few things that we need to do. We need to set up in order to start using PostgREST. The first is the URI definition, and I would like to show you this by going to the mkdocs. So the first thing that we need to do is put the URI, which will actually tell PostgREST that which is the database that it has to connect to. Second is the database schema. So what all schemas that it should look out for and convert the tables or the views into APIs. And the third important one is the database anonymous role. So imagine that whenever you are creating an API, you might want to expose few things without someone logging in. For example, and in typical cases, this will be only read request. So if you are creating an application, let's say something like a hotel, all the hotels or all the point of interests on the map, you would want user to be able to see the data without ever having to log in. So this is possible by creating an anonymous user or anonymous role, and then assigning the select query for that particular table to that particular role. And just like that, you can actually expose the read-only request for this particular API to anyone who has not even logged in. And once you do this, you instantly get an API where first, if you do like /workshops, it will list all, but you can also do filtering. And the filtering in this particular PostgREST is quite powerful, because everything that we do with normal SQL filtering Everything from the basics like finding out the workshop title is equal to, or maybe duration less than 180 minutes or something like that, all the way up to creating logical operator queries. So maybe you can say that, okay, workshop should have instructor as is equal to Krishna, or maybe the workshop duration should be less than 180. And all these things are possible within PostgREST. If you have the foreign key in your table, so let's imagine that you have workshop and then you have another table for instructor, and you are connecting both with the foreign key instead of the like varying character. You can also write the query to go within the foreign table and then get the data from there. So probably we'll have a look at that as well. You can also select few columns. So if you don't want to expose all the columns, you can just give them as a select query. And because these are standard APIs, the pagination and the ordering and everything is also sorted. So these are various parameters. So for example, you can do duration greater than 120, or you might say that title like PostgREST, or the instructor is either John or Jane. You can do ordering based on a particular column, and you can say that whether you want descending or ascending. You can do pagination by providing limit and offset, and you can also work on the relationships. So you can say that, okay, I want all the columns of this particular table, but there is a foreign key known as participant. I also want all the columns from that particular table. So you'll have once you hit this API, you'll have a JSON which will actually contain the original information plus one more dictionary containing the foreign key columns. The next is authentication and security. This one is particularly useful because what you want to do is you want to create multiple roles in your database. So it might be anonymous role, authenticated user, super admin, etc. And then you would want to create users and assign roles to those users. And once you do that, when that user will log in, you will generate a JWT token to find out what role this guy belongs to, and accordingly, you will be either allow that person to hit the API or not hit the API. So you start by creating multiple roles that you want, and couple of functions like login, sign up, maybe reset password, etc. And if you're interested into checking this particular thing out, there is a separate notebook available known as advanced PostgREST authentication, which contains everything, like starting from creating the auth users table all the way up to setting up permissions, updating PostgREST, like writing password hashing functions, registration functions, login functions, getting current user, etc., etc. All these things, because you are actually within Postgres itself, everything that you do with Postgres, like row level security and all these things are still applicable. So here you can see that after executing those functions, all the functions automatically become APIs. And then I can run something like a register user, where I can give username, password, and the role. And then once the user is registered, I can then use the login function to log them in and get the token, which ideally then I will use to call the APIs. So as I said, row level security is also possible. So user only sees their role, their own workshop automatically. And we can also build custom functions. So if we build the functions, essentially, like for example, over here we have a search workshop function where someone will pass the text as a query, and then we will just execute the SQL query, and then we will give back the result. And it's automatically converted into API. Similarly, you can also run spatial functions. So for example, here we have a nearby locations where we do lat, long, and radius in meters. And here we actually are returning the table itself. So we are returning a table with the name and then the distance. So we are taking lat long from the user, radius in meters from the user, converting our data into geography, and then doing the STD within. Funny thing is that we have like 700 functions in PostGIS, and all those functions are ready for you to use as an API directly. So you don't have to write like every single time. All these st- functions are available to you as an API. So let's say if you want to create an application where you know that you are going to use PostGIS as internal functions, you can just spin up a PostgREST and use those functions as it is. You don't have to write any line of code for that. And yeah, so similarly, we can build like real world spatial queries like nearby functions, or let's say getting the workshop based on the name. And if you want to return it as a GeoJSON, all you have to do is change the accept type from application JSON to application GeoJSON, and everything will be returned to you as a GeoJSON. Yeah. So a couple of advanced feature, you can also connect the WebSocket to PostgREST. You can also do the binary data uploading. It does not support the file data uploading, but binary is possible. You can very well run the bulk operations. It is very efficient in batch processing. You can do complex analytics. So everything that you know that you can do with an SQL query essentially can be exposed as a function. And it automatically generates the OpenAPI spec documentation. You can scale multiple PostgREST instances in horizontal. And you can, so in order for you to improve the performance, you will do the exact same thing that you do to increase the performance of your database, like making like indexes, connection pooling, caching strategies, etc. So production deployment, there is a ready to use Docker image available for PostgREST. And you can obviously deploy that to your favorite deployment strategy. So I would recommend you guys to check out the workshop. It contains all these things that we talked about, right from creating very basic table and setting up the PostgREST itself, all the way up to creating the geospatial functions with PostgREST. It contains multiple exercises as well, and the solution for the exercise as well. So use cases, if you're looking to create an MVP where you don't want to build a backend and you know that like Postgres is going to be your the actual database where the business data as well as your authentication data and everything is going to live, then this is a perfect for you. If you want to create microservices, so we also have used this particular PostgREST in many cases where we know that we want to actually utilize PostGIS function so that we don't have to write everything from the scratch again in our Python code. Instant APIs for the apps, you can also use it to collect sensor data, because if your data is going to live in Postgres, then it's just easy. And you can also make the spatial data services by using PostGIS. When not to use Postgres, so if you're going to use like heavy computational tasks, probably you should avoid this, because again, you're actually making a connection to the database and then running data over there. External APIs, so if you plan to do third-party integration, then probably this will not work. If you're going to use any other, let's say Python package or something like that, then Postgres is not the correct choice. And if you want like non-HTTP, like if you have a non-HTTP requirement, then it will not work. Best practices. So yeah, schema design first. It allows you to make the APIs based on the which follows a structure. So for every single table, even though if you're a anonymous user, you will see all the CRUD APIs available. You will not be able to hit those APIs, and you will get like a proper HTTP status code and response. So everything is managed very well, but you will see all the APIs at all the time. Use view for complex query. So views are also exposed as a API, and you can obviously implement a row level security. Create indexes for performance, version of your schema with migration. So we most of the time for authentication or something like that, we'll create a schema and we will not expose this, even though we will only expose the functions that uses the let's say the schema. So for example, authentication schema where all the users are there, we will not expose that schema, but the login function we will write in a public schema, which will actually call the authentication schema and the table within authentication schema. So something like that. Yeah, so the resources and the next step would be, you can check out the documentation at postgrest.org. You can check out the workshop, and if you're interested into learning PostGIS from scratch, I actually create a lot of content around it, and you can get the course as Ultimate PostGIS course as well. That's all from my end. Thank you.
Krishna, that was great. Thanks for sharing your expertise with us, especially making it accessible. Could you just say the name of your company
It's rottengrapes.tech.
And
so this is
yeah, why rotten grapes?
So I come from the wine capital of India, so that makes sense for the grapes part. And Rotten Tomatoes is so famous website.
Nice.
So why not?
That helps me remember it.
Yeah.
Any questions, please? Yes.
Thank you very much for the talk. And it can work also with PostGIS raster?
No. So I mean, I have
Because
not
you
tried
speak
it.
about binary, so if I create an image from my raster, it could return.
I have not tested it, to be honest, but like everything that you do in SQL is actually exposed as a Postgres. So I don't see why not. I mean, yeah.
Thank you. Just a question. In the background, is it implemented based on something like FAST API, or you
No,
developed
this is written in a language that probably is the first time that I heard, that's known as Haskell. So it's a bit difficult for me to also contribute, but like I'm contributing on the documentation and creating content around it and all that. So if you know Haskell, you can actually look at the code itself. But the community is quite active. They have Gitter. So I'm also part of the Gitter. And if you have a specific question, you can always ask these guys. Amazing. Yeah.
Questions, please.
You go back one slide to get a picture of that.
The which one?
You go back one slide.
Okay.
Nice. Any further questions? I have a question. Often when in a commercial environment, when you have a API, there's a lot of middleware and a lot of other tools that are used to create documentation. And you're saying, nah, mate, forget about it. Just do it the easy way.
Yeah. So that's what, like, if you know for the fact that Postgres is going to be your main backend, like the database, then this is a perfect solution for you. But if you know that you're going to take the data, do some analysis on it, probably use some middleware packages, then probably this is not the best solution. But still, I mean, even in your own backend, you'll still need to figure out that how do I get the Postgres data, which also means that if you are not going to write the raw SQL, you'll have to figure out that, okay, what if user only wants 2 columns? Then you'll have to write that logic. So even in your backend, this can be like one of the microservices that you run to talk to the database.
Further questions? Yes.
How does this extension uses can OIDC or any other external auth provider can be implemented within this, or do you need to add more extensions on it?
You can use that. So like all I think PostgREST will care about is that you give Postgres the role that that should be used to run that API. So if you use an external auth, that's totally fine. You can use external authentication system.
Okay.
So for example, if you see over here, this is from the workshop, and you see that all the functions that you have in PostGIS are all accessible to you as an API. So you can go, you can check out, like this one will need geometry and radius and this quad sex, and then you can run this. So this is how you get, the APIs, and you can see so many. So yeah.
So this is all automatically generated
This is
based
all
on your
automatically
schema.
generated based on schema. Yeah.
One question. Yes, one more, last one.
Is it possible to hide some of these function?
So essentially what you are seeing over here is available in your PostgreSQL query as a, so it is available to the anonymous user. So whatever is not available to anonymous user, you will not see that.
Please join me in thanking Krishna.
Thank you.